Hey everyone, ready to dive into the world of engineering? Let's get started. How LED circuits work. In this video, we'll explore the fascinating world of LED circuits and how they function. Light-emitting diodes, better known as LEDs, have revolutionized the way we illuminate our lives, from household lighting to advanced displays. We'll break down the essential components of an LED circuit, including resistors, power sources, and the LEDs themselves, to help you understand how they work. By grasping the principles behind LED circuits, you'll appreciate their efficiency and longevity, key factors in today's technology-driven world. Whether you're a hobbyist, a student, or simply curious, this video will equip you with the knowledge to use LEDs in your own projects. Join us as we shine a light on this essential topic. Essential components of an LED circuit. To build a functional LED circuit, you'll need 4 key components. 1. The LED, the heart of the circuit, emitting light when current flows through it. 2. A resistor, essential for limiting the current and preventing the LED from burning out. 3. A power source, typically a battery or power supply, providing the necessary voltage. 4. A breadboard, allowing for easy assembly and testing without soldering. Choosing the correct resistor value is crucial. Too much current can damage the LED, while too little may result in insufficient brightness. Understanding these components is key to building successful LED projects. Connecting the LED in a circuit. When wiring an LED, orientation matters. 1. Identify the anode, the longer leg. This connects to the positive side. 2. The cathode, the shorter leg, connects to the negative side. To set up your circuit, 1. Connect the anode to the positive terminal of your power source. 2. Attach the cathode to one end of the resistor. 3. Connect the other end of the resistor to the negative terminal. Using a breadboard simplifies this process, making it easy to adjust or troubleshoot connections. Calculating the resistor value. To ensure your LED circuit works properly, Ohm's law comes into play. V C IXR, where 1 V is voltage, I is current, 3 R is resistance. To calculate the required resistor value, XRs, Vs, VF. If, for example, if your power source is 9V, your LED's forward voltage is 2V, and the desired current is 20 EMR 9V 2V 0.02 AR in 350. This ensures optimal performance and longevity for your LED. Assembling the LED circuit. Now let's put everything together. 1. Insert the LED into the breadboard, keeping the anode and cathode in separate rows. 2. Connect a resistor to the cathode and then to the negative rail. 3. Link the anode to the positive rail. 4. Double-check your connections. Once everything looks good, power up your circuit and watch your LED light up. Try experimenting with different resistor values to see how they affect brightness. Powering the LED circuit, you can use various power sources, such as 1. A 9V battery, great for simple setups. 2. A power adapter, ideal for more complex projects. Before powering up, always double-check connections. To connect the power source, 1. Attach the positive terminal to the breadboard's positive rail. 2. Attach the negative terminal to the negative rail. For safety, 1. Avoid short circuits by keeping wires organized. 2. If you notice flickering or overheating, disconnect power immediately. Troubleshooting common issues. If your LED isn't working, check the following. 1. Connections. Ensure everything is properly seated. 2. Polarity. Make sure the anode and cathode are correctly positioned. 3. Resistor placement. Confirm the resistor is connected properly. If your LED flickers, 1. Look for loose connections. 2. Check if your power source is sufficient. 3. Test the LED meter to ensure it's functional. Troubleshooting is part of the learning process, helping you build better circuits in the future. Takeaways: in this video, we explored the essential components of an LED circuit, how to properly connect an LED, how to calculate and choose the right resistor, how to power and troubleshoot an LED circuit. By understanding these basics, you'll be able to create efficient and functional LED circuits for your projects. That's all for today. Stay tuned to TechBlueprint for more clear and practical engineering content. See you in the next video.